Yeah. So what I plan on doing just today and tomorrow is just kind of wrapping up trig while reviewing trig, I guess is the best way to put it. A couple things that I want to go over is the derivative of trig. A lot of times it's not tested very heavily on this AICE exam, but there are questions that you can utilize it for. So there was a question yesterday on the problem that had it was halfway down the front page, and it had something to do with cosine and finding a max and a min of it. I don't know, like a pedal, the max height of the pedal and min height. And so I thought it would probably be to your benefit to learn how to take the derivative of them just in case you want to utilize it. Okay, there's other methods to getting to the answer, but I think the derivative sometimes is the easier of the methods. That I want to go over. I also want to go over, and it won't be today, probably tomorrow, I want to go over graphing, a little quick graphing thing on trig, and solving. Okay, so it's just kind of wrapping up trig, a bit of a review for the chain rule, and for the quotient rule, and for the product rule. So it's kind of pulling it all together, hopefully through trig. Alrighty? So what we're going to do today is, first thing I'm going to talk about is the 6 trig functions and their derivative. Now, if you do me a favor and get out your bright colored sheet of paper. Okay, on there somewhere is there the derivative of the word sine and cosine. 95% sure it's handed to you on that. Yeah, it's at the top of the back of the page on the pure math. It says you have a couple derivatives there. Sine, cosine, and tangent are 3 of them. Okay, so the good news is that you don't have to learn the derivative for sine and cosine. Okay, the rest of them kind of come into play. I'll show you how they work. So you really won't have to memorize any of them if you have those 2 under control. Okay, so does anybody, first of all, let's kind of think about what does a derivative mean? Like by explanation, yes.
Like you take the exponent and you multiply it with the coefficient?
Okay, so that's the method of taking the derivative using that rule. But what exactly does it mean? Yeah.
It tells you the slope of that tangent line that hits it.
Right. It tells you the slope of any tangent line that hits it. Okay. So what I'm going to do first is I want to, if you don't mind hitting the red button, I want to bring up I want to bring up the actual, what it looks like, the sine wave. You guys know the pieces that make up the sine. So for example, visually, if I say, what is the sine at 0? Okay, like the ordered pair 0. What is it? Sine is 0. So the ordered pair is 0, 0 at sine. Okay? Then let's go to one that's a little easier to work with. Let's go up here. What is the sine at 30 degrees? 1/2. So at 30 degrees, you're going to go up to 1/2 and put a dot. Okay? What is the sine? And I'm looking at ones that are kind of easy to look at here. The sine at 45 is square root of 2 over 2, so you go a little higher than 1/2. And then you go, the sine of 60, you go up to square root of 3 over 2, a little higher than that. Okay? And then what happens when it hits pi over 2? What is the sine? 1 whole, right? So you start at 0 and you work your way up to 1 whole. Then what's going to happen? What is the sine at 120? It goes back down to square root of 3 over 2. So you're looking at a graph that goes up, hits at 1, and then starts to come down. Does that make sense what I just said? Okay, and I'm going to show you visually what it looks like. What does it look like here when we get all the way to pi? What is the sine? So your sine wave is, it goes like this and like this. And then what do you think happens the next time? It goes up and it comes down. And it goes on forever. Okay? So, I actually have a dance that I will show you. Not today. There is no way I'm moving today. It's not pretty. It's ugly, whatever I had yesterday. If you don't mind hitting that blue button till it turns green again. Okay. Now I want to show you. Oh, thank you. One of them days. Okay. I'm actually going to show you what the sine wave looks like. This, what I just put in is something called Desmos, DESMOS.com, and you can graph anything you want to graph, okay? So this is the actual graph of the sine wave. And I kind of explained it to you. At 0, it's 0. It comes up until it hits 1. And where is this going to be at? Where does it hit 1?
90.
At 90 degrees, right? And then it starts to go down until it hits 0. When does it hit 0? At 180, right? And then it starts to come down until it hits at 270, -1, and then it goes back up, okay? And so what you have is what we call one full period of sine. One full period of sine, okay? Where it goes up, down, up until it meets where it starts over. And then if you look, go this way, go backwards, it's actually going backwards on the unit circle, okay? Now, what did I just tell you about the derivative? You told me that it's the slopes, right? So tell me, for example, what is the slope at this point right here?
0.
It's 0, right? So the slope at this point right here is 0. So if I'm graphing the slope, where would it be if it hits at 0 here? It'd be right here. Does that make sense? Yeah. What is the slope of this guy over here? 0. Same thing. What is the slope of this guy over here? 0. Does everybody understand that so far? So when it's at the top of the hill or the bottom of the hill, the slope is 0. So its derivative graph would be crossed at, it would be at where it's a tall here, it would cross here, it would cross here, etc. Okay, what kind of slope do we have here? It's a positive slope, right? So it's a positive slope, meaning it's going to be above the x-axis. So if it's hitting here, it's above the x-axis, okay? What do we know about this slope?
Negative.
Negative, so therefore, from this point to this point, it's going to be below the x-axis. Everybody cool with what I'm saying? So let me show you, if I graph, give me one more, add a graph, add a graph, there, yes.
Can this slope be negative and still be above the x-axis? Because like that part right there from the top of that to like where it's going to the bottom, it's still above the x-axis.
The actual graph itself is above the x-axis, but the slope is going down. Therefore, its graph of its slope would be below the x-axis. Where you see the original graph going downward, it's below the x-axis. Where you see the original graph going upward, it's above the x-axis. So let me show you what cosine looks like. Yes?
You should probably go to the...
Oh, you should. Okay. Go ahead. Go ahead.
They don't make an announcement? I thought,
No, they
oh,
don't.
do?
Go ahead and I'll repeat this.
What's going?